Vinita Kartial, and on behalf of the Director of Jubilee Institute of Sciences and the entire Institute family, I welcome you all who have gathered here to commemorate and celebrate the auspicious occasion of our 76th Foundation Day. And the function is here on a virtual platform. The Jubilee Institute of Radio Sciences commemorates the name of its revered founder, Professor Jubilee, who was one of the great academicians of modern India. And for the history of this day, in September 1939, a committee of paleobotanists working in India was formed, with Professor Sahani as the convener to coordinate the paleobotanical research. On May 19, 1946, an 8-member committee was they signed a memorandum of association for the Botanical Society. A trust of that name was created in June, the very same year, and this trust was assigned the job of the foundation of a research institute. And by a resolution passed on this very same day, the 10th of September 1946, the governing body of the society established an Institute of Paleobotany and appointed Professor Sahani as the first director in an honorary capacity. And here we are today completing 75 years of this journey from that day, and to celebrate everything. We want to celebrate the team, the science, the growth and development, the people, the PSIP family, ever since its inception. And it's a privilege to have guests, dignitaries from various institutes, and also our superannuated faculty, staff on this virtual platform. I welcome you all. And with immense pleasure, I also express my hearty welcome to Professor Subir Sarkar from Department of Geological Sciences, Jadavpur University, Kolkata, guest speaker of this memorable day. Professor Sarkar will deliver the Foundation Day lecture on preservational bias, a journey from model to the pre-Columbian level. I request Dr. Varna Prasad, the Director of ESIP, to address us. To you, ma'am.
Good afternoon, everybody, and I welcome all of you, all the dignitaries present today, Professor Chamial, Professor M.P. Singh, Professor Subir Sarkar, and all those, everybody, all the retired people of this institute. So it's a very proud moment for all of us. We gather here today to celebrate 75 years of the formation of this institute, a product of the vision of Professor Birbal Sahni. Originally, a committee of paleobotanists came into existence in September 1939 to periodically report on paleobotanical research. Subsequently, Professor Sahni, along with 7 others, thought to bringing up a paleobotanical society, and a trust by the same name came up on June 31, 1946. Professor Sahni's fossil collection property reference library constituted the pivot around which paleobotanical research started here. The Paleobotanical Society established an Institute of Paleobotany on September 10, 1946. Professor Sahni was named as its first honorary director. For want of its own building, initially this institute functioned from the Department of Botany, University of Lucknow. Later, as land was received from the government, the institute moved to a bungalow already present on 8 September 1948. The foundation stone for the new building was laid on April 3, 1949 by the then Prime Minister Pandit Jawaharlal Nehru. It was one of those tragic acts of fate that Professor Sahni passed away just a week later on April 10. The direction, however, had been provided, and his vision was taken forward by his wife, Mrs. Sahni, oversaw the completion of the institute building in 1960. The new building, symbolizing the start of paleobotany as a science in its own right, was inaugurated on January 2, 1953 by the Prime Minister. Since then, the institute has not looked backward. The institute rose through its early years under the tutelage of stalwarts such as Professor T.M. Harris and O.A. Hoyt and Mrs. Sahni. During the period of Professor K. N. Paul as President of the Paleobotanical Society on July 9, 1969, the Birbal Sahni Institute of Paleobotany was registered as an independent body and subsequently came under its own governing body. Since many decades now, the Birbal Sahni is an autonomous institute of the Department of Science and Technology, Government of India. In 2017, in recognition of the multifaceted work being carried out here, the Birbal Sahni Institute of Paleobotany was rechristened as the Birbal Sahni Institute of Paleosciences. The newly widened mandate aims to look at understanding origin and evolution of life through time, understanding climate change in recent and deep geological times, understanding past civilization and human history, and application of paleosciences to exploration programs of oil and coal industry. BSIP is striving to attain excellence in R&D through a dedicated scientific team together with integrated innovative ideas in basic and applied research. In its broadest sense, the BSIP seeks to interpret evolution of life and geological processes involve environmental evolution and climate change through time. Initially, the BSIP laid emphasis on more fundamental aspects of Indian fossil flora, but diversified in due course by the inclusion of multidisciplinary approach to carry out high-resolution biostratigraphy, correlation of surface and subsurface sediments, characterization of source rock for fossil fuel deposits. Emphasis has been made to derive knowledge about the evolution of atmosphere during Proterozoic, diversification of early life, evolution and diversity of early land plants, interbasinal correlation of Gondwana, quantitative climate reconstruction of Cenozoic using both plant and mega and microflora, paleobiographic inferences through phylogenetic studies, evolutionary studies of insects in amber deposits, vertebrate paleontological studies, coal and lignite quality and climate of recent past, that is during Quaternary period, through the study of pollen, trading as well as through geochemistry. The paleofloristic scenarios of the bygone eras help us to figure out the past climatic and environmental changes. However, it is important to understand the climate change studies to deduce the paleo-monsoonal fluctuation during Quaternary time period. Dating and study of samples of archaeobotanical as well as studies on ancient DNA are critical to understand the co-evolution of culture and civilization, and that can also assist in terms of climate change. Not only in India, studies towards fulfilling the BSIP mandate are also being done in far and wide regions such as in areas of Bay of Bengal, Arabian Sea, Indian Ocean, including in the polar areas such as in Arctic and Antarctic regions. The Museum of the Institute offers a rich repository of fossils collection from India and received around the globe. A special attention is the foundation stone itself, put up in 1949 with 77 fossils inlaid. The Institute possesses a rich collection of literature on paleosciences in its Knowledge Resource Center. The radiocarbon dating laboratory of the Institute is a national facility in the country, and with the newly widened research mandate, the Institute has acquired the TLOSL system useful for precise dating of archaeological artifacts as well as quaternary sediments. The IRMS, ICPMS, GCMS, XRF, and wood isotope lab, which is recently introduced in this institute. Besides the establishment of the Paleomagnetic and Ancient DNA Laboratory, FESEM, confocal laser and Raman spectroscopy are also being part of national facility in this institute. The institute hosts national and international scientific meets from time to time. Yesterday, 3-day International Neckline Conference was convened. Institute also publishes catalog atlases, etc. on special occasions, besides publishing in-house journals, The Paleobotanist, which too has now been renamed as the Journal of Paleosciences. The Institute publication in recent years can be seen in a very high impact factor journals such as Science, Nature Communication, The Cell, Proceedings of the National Academy of Sciences, USA, Earth and Planetary Sciences, Science of Total Environment, International Journal of Coal Geology, Review of Laboratory Paleontology, and many more. All this has been possible with the dedication and sincerity of BSIP scientists over the years, those who have superannuated and those currently in service. We have a tradition of dedicated innovative work established by Professor Sahni himself and which we are proud to carry forward. Each scientist who has graced the laboratory of this institute has added glory to it. The most fitting tribute that can be offered to the great man whose vision brought this institute into existence, but unfortunately who could not live long enough to taste its fruit, is to be cutting-edge science. I'm happy to state that in just what we are doing as our publication and citation profile amply displays, the institute also has a technical staff that have been contributing to the institute's progress. The administration has been steady in its support from in front as well as behind the scenes. Success is often a reflection of the men that make the organization. The BSIP story is one of the coming together of each of its arms. On this 76th Foundation Day, I would like to thank all those that worked here and have moved into the world beyond. May their souls rest in peace. Those that work have superannuated but continue to be with us today, those who are presently on the rolls or having brought the institute thus far. And on this landmark day, we assume all that coming years would see even better progress, as we at the BSIP strive for greater height. At this day, I would like to thank Department of Science and Technology, Chairman Governing Body and Governing Council, Chairman RAC, Research Advisory Committee for their constant support to this institute. Thank you.
Thank you, ma'am, for giving us a very vivid picture of the foundation and the journey since its foundation and the institute as of today. As per the program, we have book releases, and today, as for the 76th Foundation Day, what better moment and what than this, and a better occasion than this it would be to release the books that are published from BSIP. We have volume 69 of the Paleobotanist Journal and volume 70 of the same journal, but under a new name, Journal of Paleosciences, to be released today. Request Dr. Nilay Grover to please help. I request ma'am and the other team members with the 3 minutes and I will be just to please release the book. As for the Paleobotanist, the first volume of the journal was published in 1952. And volume 69 is the last under this name, as this journal, as now told, has been decommissioned to Journal of Paleosciences. There are 8 research papers in this and a general article in this volume. The research article is the correspondence between South African geologist Alex L. and our founder, Professor Sahni, concerning Gondwana paleobotany, and these are the correspondence between 1925 and 1944. It is authored by Professor Sharad Master, a professor from Pretoria University who visited our institute as a member of the 36th IGC South African delegation. While in the country, he explored Professor Sahni's correspondence with Professor in Lucknow and in Delhi, and based on that research, he wrote this article. I would like to congratulate all the authors who have contributed to this volume of the Paleobotanist. Now there is the second volume of volume 70, 2021, under the name of Journal of Paleosciences. I again request all of you to please release this volume. Now, pointed out that the scope of multidisciplinary science was widely influenced, also decided to bring in this journal. And start with we decided to bring in a specific volume on paleosciences. What has been done, what needs to be done. So, this is volume is called the Paleosciences Horizon Cross and Beyond, and it has been designed to commemorate the occasion of our Foundation Day and celebrate the 75-year journey from 1946 to 2021. Yeah. So this is an integrated volume encompassing 15 detailed research subjects which brings forth many perspectives of issues dealing with geological processes, floral and faunal evolution, monsoonal evolution, climate, encompassing the entire geological landscape from experts of their respective fields. And this is the last print volume as we are stepping on a digital platform for the coming issues of the JPS, that is the Journal of Paleosciences. As the present editor of JPS, I would also like to add here that these 16 papers of this volume will cover a wide array of paleoscience disciplines and give food of thought on research problems and planning future research. I would like to acknowledge and convey my gratitude from the bottom of my heart to all the authors who readily accepted the invitation to contribute to this volume and within short deadlines, and together we will make it happen. I thank all of you for being a part of this milestone celebration of this Platinum Jubilee, which means a lot to the VSIP journey. I thank my entire team, Dr. Deepa Agnihotri, Dr. Swati Tripathi, Dr. Prasanna K, Mr. Arad Mehra, and Mr. Rashid Ali, who have meticulously worked all throughout, and me and my team have been fortunate to receive the support of our chief editor, the director of the Institute, Dr. Vandana Prasad, at every step. Thank you, ma'am. Now it is the time for the Foundation Day lecture. Preservation Bias, a journey from modern to the pre-Cambridge deposition regime. And before we listen to our learned speaker, it's my pleasure to introduce him. Professor Sumeet Saswar is from Department of Geological Sciences, Jadavpur University, Kolkata. He is Masters from Bardhaman University in 1984 and PhD from Jadavpur University in 1991. We all know that he specializes in the field of sedimentology, basin evolution, and sequence stratigraphy. He has disseminated his knowledge in all these disciplines to his undergraduate to master's students, along with taking up sponsored courses on the courses for DSC, for UGC, and for industry too. His research interests are species and sequence architecture of different Indian Proterozoic basins, with special emphasis on Proterozoic Vindhyan Basin of Central India, Marwar Basin, Halarki Basin, and basin analysis of pre-Cambrian sedimentary succession, distinctness of pre-Cambrian sedimentation and sequence building, with special reference to bed form evolution, sedimentation dynamics, stratigraphy, architecture, paleobiology. And he has been in collaboration with international collaboration with Pretoria University, South Africa, Munich University, University of Alberta, and many national universities and institutes also. He has 27 years of research and experience and 18 years of teaching experience. He has a number of fellowships I'll name some. Fellowships from Government of South Africa in 1991 and again in 2012. Then inside DTF Exchange Program 2007, inside ASTF Exchange Program 2011. He has guided several PhDs and MSc theses. He has published in peer-reviewed journals and books, many as more than 75 publications, and several edited volumes of in sedimentary geology. Like I named some sedimentology and paleontology of drift basins, sedimentary systems, and sequence stratigraphy related to pre-Cambrian sea level change, pre-Cambrian. Then his latest is the latest volume on Mesozoic stratigraphy of India, which we are seeing nowadays. He is a National Geoscience Awardee of 2011, a member of the Executive Committee of Indian Association of Sedimentologists, Editorial Committee, member of Journal of Paleogeography, and in 2000 he was elected member in Geologic Global Pre-Cambrian Sedimentation Syndicate, GPSS. We welcome with this brief introduction. I can go on and on, but with this brief introduction, I welcome you again, sir, for this to deliver the Foundation Day lecture. Over to you, sir. You can share your screen now. Yes, sir, we can see your screen.
Hello, am I audible?
Yes, sir.
Okay, good afternoon to all of you. Respected Director, Dr. Bandana Prasad, my colleagues at BSIP and other dignitaries present in the meeting. At the outset, I'd like to convey my thanks to the Director, Dr. Bandana Prasad, for inviting me to present, to deliver this lecture on this auspicious day of BSIP. First of all, I will thank you, Vinita, for the excellent introduction of mine. I don't know who am I, but one thing I can assure all of you that I like teaching. I like to be a good teacher. So before beginning of the lecture, I would just request, particularly the junior scientists of BSIP, if you have any queries, anything, even during my lecture, if you fail to understand anything, you freely ask to me. I don't mind anything. Okay. So today I will speak on sediment preservation. Sediment definitely preserved. Otherwise, how we encounter sedimentary rock in rock record, sediment in rock record. Actually, it's not a lecture. I will share my experience, my feelings, my weird thoughts regarding the net sedimentation, and I shall talk on preservation of sediment if there is any bias, or if there is anything bias. So what is that bias? So I will go on talking on modern sediment as well as ancient sediment. So sediment actually covers 75% of the Earth's surface. But if we distribute all the sediments over the surface, it will cover only 0.5 kilometer. Obviously, sedimentation or sediment confined to the thin skin of Earth, and where only surface process dominate. Now, the surface process is strong enough, particularly in shallow water environment, to erode many things in many sedimentary record. A person standing on a beach, really it is hard to believe all this sediment will be preserved, or part of this sediment will preserve in the rock record, though there is constant reworking going on. Just if anyone, in fact, this was my feeling when I visit first time the modern environment, how this sediment has been preserved. Constant reworking is going on. So how this sediment get preserved? But it is true, sediment get preserved. That's why we used to get sedimentary rock. We do different type of analysis and all this. But yes, how much sediment is preserved? So we have some lingering legacies of old-fashioned uniformitarianism and sedimentation process. We tend to favor continuity over discontinuity, gradual over spasmodic change, even average condition over extreme condition. This is our general tendency to think. So my major focus of today's discussion on preservation of sediment. So do they have any bias? The answer should be yes. Does every bit of sedimentation history always recorded within rocks? The answer should be negative. So why I'm claiming all this, I will discuss this step by step, and I will have a journey from modern environment to Precambrian environment. So imperfection of geologic record, it has been postulated by Charles Darwin long back, because people like Charles Darwin, they can feel, though at that stage geology was not, or earth science not at this stage, but they have the feelings because of episodic nature of stratigraphic record, episodic nature of sedimentation behavior. The consequence is the severe incompleteness of a stratigraphic record. Many gaps recorded can be clearly seen, as for example the time gap between the Proterozoic and the Gondwana. Anyone can observe in peninsular India, in Gondwana sequence, below the Gondwana sequence. But there are many breaks which are not that much apparent and remain concealed. In fact, it is virtually impossible to demonstrate that a given sequence is free from stratigraphic breaks, although we confidently frequently speak about continuous sedimentation. So now, these are the satellite picture of Odisha coast, the upper one, and the lower one, this part, I will show some case history and photograph from this area, Chandipur area, and few from this Dagara beach. And this is the, this portion have been enlarged here. This is the a back barrier estuarine tidal complex exposed in Chandipur area. It's almost like a laboratory for a sedimentologist and a biologist. Okay, so these are and these are the ancient sequence. This is Vindhyan, and this is part of Marwar group, Jodhpur sandstone, part of Marwar group. I will cite example from these sequences. So one thing I will mention, this the photograph I will show, not all photographs I have taken. Many photographs my students have taken in different times, and we used to visit this environment, particularly this almost every year. So for my knowledge goes starting from 1990, I have missed only 2020. I have never visited this place. Otherwise, every year I used to visit. I am there for learning, and I used to take my student as well. So many photographs they have taken. I acknowledge their contribution to this lecture. So this is the part of the vast intertidal flat exposed in Chandipur. You see, you can, yeah, so the intertidal flat is excellently exposed, and intertidal flat, we all know, is basically a low energy environment where silt or fine sand, mud, they can deposit. But you see, within this relatively calm and quiet environment, there are some mesoscale scour in the lower photograph. So this scour I noticed in possibly 1990. But this photograph, of course, is a later photograph. one of my students standing here near a scour. You see the length of the scour, and if you visit this Odisha coast, Chandipur, you will find in different season they develop. There are reasons behind it, and I published it in way back in 1991. So I'm not going to the detailed story of this cover, but one thing is true that even within a low energy environment, there are something which can produce this sort of scour. And you see, in intertidal flat, as mud is abundantly present, scouring mud is little bit difficult compared to sand, or if you can erode easily sand because of its non-cohesive nature. But because of its cohesive nature, it is difficult to scour mud. But you see, so many. So this scour has laid away some sediments, and some sediment has been lost. So some record from the stratigraphy, if it get preserved in ancient rock, some portion of the sediment getting lost, and some record as well lost. You see this photograph from, of course, these two photographs from Dagara beach of Odisha. So this is a rhombic ripple. You see, who are working in modern field, these are very frequently you will get in modern beach. This is real marks. Even you go through the books of Professor Rayanek and Professor Singh, you will find plenty of real marks photograph from modern environment. But they are hard to get from ancient sequence. So they get eroded. So as a present day, we are getting all these real marks and rhombic ripple. So at ancient time, they used to form in beach. So beach we get in ancient sequences, but very rarely find this sort of structure because of this low preservability. Because the structure are very small scale, their height is not good. Those are the reason for why they get less preserved. So if you observe this ripple set, you see these ripple are flat crested. That means the ripple crest has been eroded. You see here, this is a dune field near the bar complex of Chandipur, and this is the upper part has been washed out by some current, of course. So we know the mechanism, but definitely some record has been eroded and some record is lost in the stratigraphic record. So this is a trench section in the modern environment. You see, it's a continuous lamination is present, but really they are continuous. If it is continuous, then why this bedding plane appears? In fact, bedding planes are the pause between two beds. If there is no bedding surface, no gap, bedding plane cannot find a continuous the full within this section. You will get a single bed. Not like that. There are a number of beds and bedding surface. So bedding surface separate the beds. So are not they many unconformities? The interval of non-recorded geologic time exceed many times than record. Even after the initially we have the idea that okay, deep water there is no erosion, but after the DSDP project, it has been found that half of the sediment has been lost even in the deep water environment. Naturally, in the shelf or the shallow platform where sedimentation process is dominant, their gaps are more. So in stratigraphy, we used to get this famous word, there are more gaps than record. So really, there are gaps. So if you now compare between a Phanerozoic unit and a Proterozoic section, you will find the net sedimentation is more in case of net sedimentation means sediment deposition and minus the sediment erosion. So that is the net sedimentation. Net sedimentation is more in Proterozoic compared to Phanerozoic section because erosion process is more active in your Phanerozoic. So the reason behind it, possibly the microorganism prefer to grow in Proterozoic or Precambrian because there was no metazoa, almost nil. I should not say no metazoa, but before the Precambrian Cambrian boundary, microbiota or microbial mat prolifically developed on the sediment surface. So this help actually this form cover within above the surface of the sediment, and they help to get preserve more sediment in Precambrian sedimentation system. So because of the absence of grazer and butter, so in modern days, this biota is restricted to in some places where suppose in Shark Bay, biota is microbiota is present abundantly, though I have not seen, but the reason is the salinity of Shark Bay is very high. Yellowstone Park you visit, plenty of microorganisms you will find because of the high temperature. So this microbiota has a great role in preservation of sediment. In fact, I have taken this Proterozoic example in my lecture because of this presence of microbiota is more in this Proterozoic sequence. So this absence of microbiotic layer in the Phanerozoic is affect Phanerozoic preservation. On the other hand, favors Proterozoic sediment preservation. So this is a photograph from the microbial mat colonization on siliciclastic sediment surface on a modern environment in Chandipur. This is a relatively restricted swampy area from where this photograph has been taken. So these are the microbial mats of present in limestone stromatolite. I will not speak about this thing because you have the topmost Indian expert on stromatolite on this, so I should not speak much about this. And microbial mats related structure in siliciclastic rock already people know. That's why I will not elaborate this thing because already books has published. This book has been published in 2007. So people know this, all this. So now I will start from this Orissa coast. The Chandipur Beach Barrier Complex present here is setting almost as I mentioned that as good as laboratory, where different types of structure of very low relief form, but I fail to just replicate them in ancient sequence. I fail to identify. So I started my modern days fieldwork from 88 onward. So there are one structure called settle. I used to see this setup from in the modern environment from the very beginning of my journey. But I was astonished there was no report of setup in ancient environment. So my queries was why they are not so abundantly present in everywhere, not only in eastern coast, even in western coast. This setup structure. Setup is a very interesting structure and very informative. It can give you many things. I will come step by step. So setup form through accretion of wind deflated sand on a lee of minuscule obstruction in the supratidal intertidal depositional regime of any modern environment, and they form in swarms. So not one, two. Suppose you are getting one structure, and if you interpret on the basis of that one structure, people will ask you why you are solely depending on this single structure. But this is the advantage. They form in swarm. So there was no record. So this is the setup structure in the modern environment. This is from eastern coast of India. This is from western coast of India. Setups are primary sedimentary structure. These are the description: spatulate with one end pointed and steep flaring other end. This flaring end give you the direction of the wind. Now you see this setup is formed in the air-water interface, and the primary structure which are forming in air-water interface, as for example adhesion ripple, is very rare, hard to find. Even in 90s, if you can report one adhesion ripple, you can have a paper in sedimentary geology or sedimentology. They are so valuable because their preservation potential is very low. So now, but you see, advantage of this setup, sometimes you see for a sedimentologist it is not a matter to get the paleocurrent direction, but suppose a biologist working on a sediment study rock, so he needs some data, so paleocurrent data. So if he or she can find out some setup, it is easy to determine the paleocurrent direction. So from that point of view, it is also easier. The flaring end consistently oriented down current direction. Okay. So as it is formed in air-water interface, so moisture within the sand and air, because of less density, it has limited lifting power. And so that's why even a minuscule obstruction could have developed a clear wake zone in the lee side, resulting the localized accumulation of small ridges of sand extended downward of the obstruction. This is the way how this settle form. Okay, so little bit history you should know about the settle. That is more interesting. You see, one fine morning in 1974, I know that story because I have a little bit work with Friedman, so I know the story that Friedman and Sanders identified this settle in a modern day environment in somewhere in Gulf. Okay, so one fine morning they went to the beach and they identified this structure. But it was published in 1974 Sedimentary Petrology. So, but you see, then after many years, settle, I have never seen any record from modern environment, and naturally, consequently, the structure generally omitted from the textbook of sedimentary rocks and remain unfamiliar to sedimentologists. Even most of the teachers, they don't think that it is necessary to use this structure in their sedimentary classes. I also don't use this thing before my publication. So then, but this was in my mind that why this photograph is from. So how the name derived? It is almost look like a flute, but flute form on the sole of the bed. We used to get it on the sole of the bed, and it is on the surface. So the setal naming, they have FLUTES. This is named after the backward spelling of the word flutes. Okay. So so and this is from the Sonia sandstone, and this is of course Upper Bhandes sandstone of Indian supergroup, both from Indian sequence. So swarms of unidirectional setup. Swarms, this is important, occur on the multiple belts of a well sorted sand. If the sand is well sorted, preservation of any structure is difficult. So the Sonia sandstone at the base of Marwar supergroup, we have identified this structure, the Sonia, and Upper Bhandes sandstone at top of the Vindhyan supergroup of central India. One thing we should keep in mind: if something not in my mind, that I can get this, you will never get. This is the common psychology of a person. If you have the okay, these are the thing I can get in my section or my area, so you can try for it. So I have in mind that surely somewhere it should occur. So, and really, I got it in Sonia sandstone. This is Sonia sandstone, also beautifully exposed in Rajasthan, and this is the from the Upper Bhandes sandstone of and they, you see, as we have seen in modern day environment, they are forming, or they are just resting in swamps. So it is very advantageous to get the direction. So these are the data from ancient environment. I compared this ancient and modern, and so you see the Aeolian direction. Sometimes it is difficult to measure, and the setup direction. You see, this is from Sonia sandstone, and this is from Upper Bhandes sandstone. Almost it is equal. So in both cases, setup are preserved in well-sorted sandstone associated with planar lamination, parting lineation, current crescent. These indicate it was a high energy environment. Still it get preserved. So setup are found in association. These are the association. In fact, in Sonia sandstone, I have observed that they are present along with inversely graded translated strata, crinkle, adhesion, lineage. So that indicate that they are association. So suggests preservation of intertidal, supratidal zone. Sometimes for many people, it is sometimes difficult to infer about the depositional area. So if you get some settle, then it is easy to identify that okay, these are the so now, so naturally the question arises in my mind, why I'm getting this into succession. So as I mentioned earlier that Chandipur is an experimental house, experimental lab. So prolific microbial mat growth present in the swampy area of where relatively less microbiota pressure. Okay. There we performed this experiment. There was mat layer, and this mat layer desiccated because of the exposure, and and they formed the mud curls. So this mud curl actually actually behave as an obstruction, and on this surface, this settle form. And initially we used to stay there for 3 weeks as well. So after a few days during the full moon, the surface is became wetted. Again, there is a layer of microbiota, and in this layer, you see there are microbial mat layer development on the and the settle underlies it. So then it come to my mind that definitely microbial mat layer can be a shield so that they can get preserved in ancient environment. And I get the answer why they are present in Sonia Proterozoic, New Proterozoic Sonia sandstone and Proterozoic or New Proterozoic Upper Vande sandstone. I get the answer because microbiota development was maximum in this horizon. So being positive in relief and very small, minuscule in size, forming within well-sorted, non-cohesive product of high energy environment. And not only this, it is not a dynamic bed form, it is a static bed form. So preservation potential is low, still it preserved. And this explains why their ancient counterparts were so rarely exposed. And you cannot expect too much development of microbial mat layer or microbiota after the boundary. Boundary means Precambrian Cambrian boundary. We all know that there is a decline in microbiota. Yes, microbiota is there, but the microbial form has changed. So so now settle used to grow, definitely settle used to grow in Phanerozoic time as well, as frequently as they were forming in the Chandipur or in the western coast. But they, their preservation was impossible because of non-availability of microbial mat layer, which can protect them. So the only example described from Proterozoic age when microbiota thrive most prolifically, and this definitely increased the preservation potential of sedimentary unit manifold. So preservation of settle in the Proterozoic thus causes no surprise and speaks strongly for the temporal bias of preservation during the Proterozoic time. Okay, this is all about my one example. My second example was on influence of microbial mat on sequence architecture. Sequence architecture, after the arrival of sequence stratigraphic concept, we developed a little bit. So I have been this idea in my mind. So if can we just put this sequence stratigraphic idea straight jacket in a Phanerozoic in a Proterozoic sequence, because it was primarily meant for Phanerozoic sequence. You see, this photograph I put it because you see the preservation potential in Precambrian. This photograph is from Chorat sandstone, and you see this is wave ripple, no doubt, and it has the median ripple as well. This median ripple also preserved. Median ripple preservation is very rare. Even in modern environment, you may find occasionally, but in Chorat sandstone, you see this this sort of ripple you can observe frequently. So I just intentionally I put this photograph here. So again, this is the lithological map of Vindian supergroup, and this is from I will cited this sequence architecture example from these two formation, one in Jodhpur group and other two formation. One is not formation member from Vindian group of super group of Central India. So this is a section just to show there are different types of microbial mat structure in Jodhpur group, particularly the marine part, and we classified it. But this has been published by many others as well. So we have a classification on this. So the next photograph. Yes. Once more, the photograph I showed earlier. So implication of microbial mass for the sequence stratigraphic architecture are most evident in proterozoic section, but it has been ignored all through. Ignored all through because the people who prepared this sequence stratigraphic concept, they were mainly, they were oil people. They were relatively busy with, more busy with Phanerozoic section. So, but you see, things has been now changing and changing very fast. You see, a few days back, our ONGC published a Proterozoic volume on this for their oil maybe their next destination to Proterozoic basins of India. This is a very good news, particularly those who are working in Proterozoic sequence. So, influence of sequence stratigraphy based primarily on, as I mentioned, Phanerozoic case studies. So, influence of microbial mat in sequence architecture remain largely overlooked. But you just see here, this is a modified picture after Bodzar and Shamuntu, one of my students, did PhD with me. So you see, in case of Proterozoic, basically sequence stratigraphy speaks about the net sedimentation. So what is the and relative sea level? Even if the relative sea level is rising and sedimentation rate is faster than the relative sea level rise, ultimately you will get HST, means you will get progradational sequence. So sedimentation or the net sedimentation is the major thing in sequence stratigraphy. So how they are affected in case if you consider perturbation, preservation of internal structure, erosional record, surface irregularities, sediment thickness, all these if you consider between two sequence, one in Phanerozoic, other is Neoproterozoic, surely there will be more sediments in this part in A. So naturally, if sedimentation rate is more, if more sediment get preserved, so naturally you will get more HST. So this was in my mind when I start searching in Proterozoic sequence. So this is some a sequence from Jodhpur sandstone, Jodhpur group, Sonia sandstone. There we have noticed that after just developing some lithologic section, that there are two HSTs in between only a TST, and TST is present only in form of a transgressive lag. No sign of transgression except the transgressive lag. So that means in case HST is dominant. Again, we back to Vindian. There also we have found that when in Chorat sandstone, only one HST make the Chorat sandstone. And Precambrian sequence, so we can lack well-developed transgressive system tract. So the question is why transgressive system tract generally less compared to your progradational system tract. That means HST. TST compared to TST, always there will be more HST in Phanerozoic as well as in, but in case of Proterozoic, the thing is even less, the transgressive system tract. So I got the idea, so why this is so? Precambrian sequence, lack of well-developed transgressive system tract and are dominated by stacked top high-stand system track that may separated by thin veneer of transgressive deposit, transgressive lag, as for example, in case of Jodhpur sandstone. This is a section from Shirbu shell. There we have identified many parasequence set, but all these parasequence set overall constituting are coarsening up. As a whole, they are coarsening up, and individual parasequence, if you consider, they are also coarsening up. Parasequence set facies package constitute the individual parasequence and their field illustration from Shirbu shell. Okay, you see the man sitting here, one of my students now in ONGC, he is sitting on a sand surface, and if you see the sand increases up the section. So the small parasequence as a whole, if you consider the overall from the Shirbu shell to Upper Bhandes sandstone, there was a progression, clear case of progression. So this stacked package of normal regressive system track should characterize the sequence stratigraphic architecture in proterozoic succession instead of what we used to get transgressive regressive system track usually we found in Phanerozoic succession. This is the major difference between, in fact, when I have this idea, I talked to one of the leading sequence stratigrapher in the world, Octavian. Incidentally, he's my co-worker in this paper as well. So, really, we search at least three sequence, three stratigraphic sequence where I go that the HST dominate and no TST is present there. Though if TST is present, they are present in form only a transgressive lag. So Shirbu shell and Chodar sandstone, they are constituted by number of HSTs, not even the transgressive lag. The apparent absence of transgressive system track between the HSTs in all three sections notable and can be ascribed to combined effect of low gradient depositional surface, as we know in case of epyric seed, and the prolific growth of microbial mats. Definitely, mat help to preserve more sediment in the Precambrian time, and that's why if the sedimentation rate is higher because of the mat cover, naturally, even there is a rise in sea level, we will get HSTs. That is true in case of Phanerozoic section as well. So the mat infested seafloor might have restricted erosion, concomitant sediment supply, enhance the sediment preservation bias, and facilitate formation of HSTs in the sequence architecture of Precambrian formation. So from if we analyze the whole part, even in Precambrian modern days and the Precambrian, you see preservation always has a bias. Thank you. If you have any question,
thank you so much, sir. And this was really nice, lovely journey from the modern to deep time. And we have embossed it again that the present is the key to the past. Unless and until we are sensitive about what is being deposited, whether it's a tiny sand grain, we cannot understand the past depositional thing. And very nicely, when I was doing my master's and bachelor's and master's early 90s, we never, in our sedimentary courses, geology courses, we have never, come across these terms. So it's so nice that, so maybe, by this, some of the interpretation, some of our understanding is not so good. But this was really an eye-opener, sir. And you explained it so well with such real-time examples. I really congratulate you. And I don't know if somebody has questions, but it was really nice. Thank you so much. Anybody, if you have a small question, you can take it. Otherwise, we take the program over.
Text box. Chat box. Chat box.
Chat box. Okay.
Okay. Just please, if you can open your chat box.
Thank you, sir. Very.
Yes.
In chat box, you see,
Okay, it's a time.
one of my students. No question.
No question.
Just convey her thanks. Thank you, Nivedi.
We will have interaction when you come here as RSC member.
Yes.
Then we will have many members.
That would be
Yeah, there are many questions. We would like to listen.
Yeah,
like to
I
interact.
have one very small query.
Yeah.
Yes.
Congratulations, Professor Sarkar, for the wonderful lecture and the wonderful photographs you showed from the field, from the coastal region as well as
Credit
from
of the
the
photograph
union.
goes to my student, mainly from my students. Okay.
Yeah.
Thank
So,
you. What is your
number
question?
one, regarding flute cost, you said that the difference between the flute and the second primary sedimentary structure, opposite in spelling to the flute, that the flutes are found at the bottom, whereas that is found on the top of the bed. Whereas, to the best of my knowledge, flutes are also found on the top of the bed. They are
Right.
preserved. They are preserved at the bottom of the bed.
Sure, I mean so.
Yeah.
I
And
think
second,
so.
if you have reported,
And one thing, Dr. Dhruvo Singh, Professor Dhruvo Singh, one thing, the name is not given by me, name is given by Friedman and Sanders, okay?
Yeah.
And you were right that structure cannot form under surface.
yeah.
It gets preserved under surface.
And the second is regarding sequence stratigraphy. You have documented the high system track, HST, and the TST transgressive system track. So I hope that you have identified the TST and transgressive system track and the high strength system track in the field. Have you observed the condensed sequences?
I cannot hear you. Please repeat once more.
If TST is there and HST is there, then we should get, I hope that condensed sequence also.
No, sorry, yeah, you rightly pointed out, but you see, I missed the TST. Actually, there was no TST. Only in case of your Jodhpur sequence, that is within Sonia sandstone, there is a transgressive lag which give you the story of whole transgression, everything. And there is no question of your condensed section because all are HSTs. So if they are all HSTs, so question will of condensed section will arise if very good TST is present, and above the TST you can, and below the HST you can expect this condensed section.
Because Professor I.P. Singh, he has reported condensed sequence from the Chitrakoot region in the Vindhyan.
Hello?
Yeah.
And
Yeah.
second,
Yeah, but you see, the condensed section surely not reported from Bhandet sandstone. In Vindhyan, there are other areas. There are, if you go through the place, what is called Khenjua section in Chorat, when you are coming from just walking from porcelainite formation to Kuldaha shell, you can have a chance to get this condensed section, but not in the upper Bhandet sandstone, not even within Shirbu shell. So maybe there are what we have found in or we have published, that is the HSCs, they are mainly composed during the sedimentation of the transition between Shirbu shell and upper Bhandet sandstone, and of course in Jodhpur Sonia sandstone.
and the last
Sonia
question that
sandstone,
will
we
be,
recognize the transgressive lag only in support of transgression. Okay, next.
The last question that will be useful for all the workers, that how to identify the sequence boundary number 2 in the field.
Pardon again.
How to identify the sequence boundary number 2 in the field.
Oh, see the sequence boundary for if you ask me the question, it is easy to answer. But easy to answer means I will answer you. You identify the unconformity, and between two unconformity there is a sequence. But identification of unconformity, particularly not only unconformity and then correlative conformity. Unconformity you can identify readily if you have some idea about the sedimentation history, but its correlative conformity really sometimes difficult for me as well. So to establish the sequence, you have to have the identification of a unconformity and its correlative conformity. So, but you see, sometimes the exposure does not permit. But this is the thing how you should identify a sequence. You have to identify the unconformities.
Yeah. Okay. Thank you.
Thank you, Professor Hussain, and thank you, Professor. Arvind has a question.
Arvind.
I have a question regarding preservational bias in marine cores and how to identify them. It's in the chat box. Arvind K.
Oh, Vijay Rathore, please. Vijay
No, it is Arvind K.
Yes, yes, sir. Good afternoon. This is Arvind Singh, sir.
Oh, Arvind.
Yes, sir.
Yes. Arvind,
Sir, I have a very small question regarding the marine course, preservational bias in marine course, and how to
Arvind,
identify
little bit louder, please.
Sir, I have a question regarding the preservational bias in marine course and how to identify them.
Preservational bias
within the marine course, when we have a core and the sedimentation in the marine system is continuous.
Really hard to. I cannot hear you properly. Only thing should I repeat the question, Arvind? Is the question like this? You have a core and you want to identify the omissions or the
is there any preservational bias?
Depositional hiatus.
Yes.
Achha. So if you have the core, it is expected you have some, you see, hiatus can be of day scale. Suppose a lamination forming today and lamination forming tomorrow, in between there may be some hiatus. Now first you just you look at what type of hiatus you want to identify. How much gap you want to, maybe 1 day gap, or maybe you see between a spring tide and a nip tide, or between full moon and new moon. So scale of hiatus, this you have to fix up. And now if you say, sir, I want to get some distinct boundary, if you identify, if you have some core, good core, you may have some distinct boundary. And if you get the boundaries, then you try to explain the sediment between the sharp changes. Okay, I think that would be the better method to identify the hiatus, if any. Okay, Vijay, you.
Yes, sir.
Vijay.
Yes, sir. Sir, thank you for the lecture. It was truly an insightful one. Sir, I am just a research scholar and very naive in the research field. Sir, I have a small query regarding why this microbiota is more efficient in preserving the sediment in Proterozoic as compared to in Dendrozoic. Even even we are getting lot of macrofossils in Phanerozoic, why they are not that efficient as compared to the microbiota present in the Proterozoic? This is my query.
Okay, your question is like that you are getting abundant microfossil in Phanerozoic section, but you are not getting
Yes,
that
sir.
much microbiota in the Precambrian.
Yes, sir. Why this microbiota is more efficient in Precambrian? More efficient in Precambrian as compared to Phanerozoic?
Because the if you so if I'm sharing one of my experience with you. If I am you see there is a flat tide and a ebb tide. In between between a flat tide and a ebb tide, there is time gap of 6 hours. So in a modern environment, if you stand for 6 hours in the beach, you will find within the 6 hours time, there will be a thin veneer of yellowish layer, which is consists of microbiota. Their growth rate is very fast. If you visit Darjeeling this year and next year, you will see this much thick of because of moist environment, algal layer in the wall of in some wall. To point out, so their growth rate is very fast compared to now. Before the advent of this metazoa at the Proterozoic Cambrian boundary, there was no one who can graze over the sediment. That is why this microbiota was abundantly present during the Proterozoic time. Even their thickness was so much. I have heard from an oil expert. He claimed that in Phanerozoic time, oil is used to get we used to get in deeper water, so that organic matter can preserve and oil can form relatively deeper part of the shell. So, but in Precambrian time, the mat layer thickness was so high, even in shallow water, so they may expect a good amount of organic matter even in shallow water area as well. So preservation was very good because of absence of microbiota. If you visit Yellowstone Park, you will get thick amount of microbiota because grazer are not there. So where grazer is absent, you will get this microbiotic layer.
Okay, sir.
In
Thank you.
restricted environment, and Precambrian environment was almost restricted. Restricted in the sense not geologically, but from the point of view biotarvation or metazoan presence, they are restricted. There was no serious scale metazoa.
Okay, sir. Thank you.
I think we are.
Vinita just wanted to say something.
Ma'am wanted to.
So, Dr. Sarkar, Professor Sarkar, it was a wonderful talk, and we really enjoyed it. And I just one request for from BSIP, let us plan a field visit for younger scientists and students in Chandipur area. So that in future, like it would be really nice that people will also learn in modern environment and how to relate them with the working on the older sediments. It's really nice. We enjoyed your talk.
Context, I like to mention, I don't know whether the junior scientists know it, Dr. Vandana Prasad herself once came to Chandipur. That was excellent.
Yeah.
She's
wonderful. I really learned so much in that field, and which I can apply in my older
story. Scientists like Vandana suddenly came there Of course, this is a laboratory. It's very good for learning. Excellent area for learning.
Yes, thank you.
Dr. Varma used to tell us and narrate about her experiences of that.
Dr. Santosh Pandey has written a question. If we could float in siliciclastic sediment but filled with carbonate, shall we please explain the process? Acha, but filled with carbonate. Yes. Santosh,
Can you hear me?
Santosh, okay, Santosh, I know Santosh, that's why I am calling Santosh. Yes, Santosh, it is possible, but because suppose you are getting some flute or flute-like structure and filled up by carbonate, because carbonate sedimentation, even that surface can be filled up in later during diagenetic stages by carbonate, because groundwater carry carbonate frequently. So this is possible, but only suppose you are getting a fluid filled up by carbonate and again siliciclastic. No sedimentary process can explain this. Only thing you can get when it has been filled up by during the diagenetic process.
Okay, thank you, Santosh. Thank you, sir. Sir, if you could please stop presenting your screen for, yeah. So I would request everybody to just switch on the camera so that we can take a photograph with, your faces on. Sir, if you could stop sharing your screen. I again thank you for this very, such a interesting foundation lecture. And I congratulate you for all the work that you've done and, the teaching, the researching.
Thank you everybody for sharing and asking some question. Thank you.
Yes. So, please stop presenting your screen.
Sharing your screen. Yeah.
Stop sharing your screen.
So I should leave, huh? But I like to.
No. You please stay on.
You don't have to leave, sir. You just stop presenting, yeah.
Stop sharing your screen.
Stop presenting.
Stop presenting. Okay.
Virda, you have given us a lecture, now I will give you a lecture now.
Yes, sir. Now I request if everybody could switch on the camera so that we can have few good photographs. It would be wonderful if we would be offline, but yeah, do it like this. Instead of the icons, like we can see your faces here, yeah. Everybody, Ramanan Sagar, sir, okay, he's talking from two. So yes, sir, here header, here in the screen. And then we can just close the screen and do the second one also. Yeah. How do we do? Thank you, everybody. Arrow indicator how?
Old version है ये.
And please, the people working of the SIP, you can also take photographs so that you can share it with us and we can share it with all. Thank you, sir, again. And now we take the foundation day function further. And now I invite Professor Mukund Sharma to brief us of his views on the radio sciences co-orders. Sir, please.
Thank you, Dr. Vinita, and thank you, Professor Sarkar. You have taken us on a journey from modern to the past, but this is not my term. I will be taking you on a journey from past to the present. So this is what I have to say about the paleosciences. First, on the occasion of the Ganesh Chaturthi, I pay my reverence to Bhagavan Ganesh, whose presence Indians invoke on the beginning of every event. Let his blessing be on each of us. I do not know and have no idea whether Professor Sahni was a spiritual person or an atheist, but I certainly know that on one occasion of the foundation stone laying ceremony of the institute, he said, and I quote, "For what is it After all, the pious men worship in a stone which they place in a temple, but an idea or an ideal, a great truth, a hope or wish for a higher existence, whether in this world or in the next. And what is that this stone symbolizes? The great fact of the antiquity of plant life on the globe. The intellect of man ever striving to bring that fact more and more clearly to light, revealing different stages, not only in the evolution of plant kingdom, in a more and more orderly and understandably sequence, but also the evolution of his own poor understanding of these truths. The very construction of it, the flaws and the imperfections in its entire makeup, the labor that has gone into preparation, and are all symbols of our imperfect and helpless effort at constructing something new, something worthwhile, unquote. I am convinced that he worshipped the life once present in those stones, which we call the plant fossils, or for that matter, fossil of any living creature. Today, we have assembled to celebrate the completion of Platinum Jubilee year of our institute, an occasion undoubtedly very important in our life. For that matter, we are celebrating an edifice made up of brick or mortar, or a dream visualized by a person who did not survive to see it come true, or an association of men to constantly enrich the knowledge about life and our own existence on this earth, a bit by bit. Or in Sahani's parlance, seekers after truth, a term commonly used for philosophers and spiritual seekers. Or none of these. 75 years are a long period in human life, but on the geological time scale, it is not even a fraction of a second. We are all on both hands. This institute is both a result of human perseverance over the years and to unravel the millions of years creation of nature. Let us see for a while how we treated on the path Professor Sahani charted out for many of us. My impression and narration is based on what I gathered from reading the then contemporary writings, information I gathered from his students, associates of Mrs. Sahani and his family members, and of course over the years rummaging through the archives of the institute. My mind goes back to 75 years ago when the country was passing through great upheavals of freedom movement and vagaries of post-World War II. In such a tumultuous period, Professor Sahani showed a seed of establishing an institute of paleobotany. Let us see how it unfolded in the years to follow. I take first 25 years of institute history, that is 1946 to 1971. Professor Sahani wanted to change the prevalent status of studying the Indian fossil treasure by other experts, mostly Britishers, by nurturing a dedicated band of experts to study the plant fossil in country. A few Indians as well as a Chinese student were groomed and received PhD degree under his tutelage. These were formative years. A firm foundation of science was about to be laid, but the destiny was not so gentle. Visionary was snatched by cruel hand of destiny. The brainchild of Professor Sahani almost got orphaned. The only ray of hope was his wife and students, who were privy to Sahani's blueprint of future Institute of Paleobotany. Onerous responsibility fell on the shoulders of those close to Professor Sahani to realize the dream. They did everything possible within their means and powers. Mrs. Sahani, though not a scientist herself, proved to be able mentor. She took charge of bringing money, international expert to steer the institute in early stages, and grooming students who were attracted to the institute in awe of Sahani. PHU and AMU were the two institutions establishment of which were the result of their founders' determination. I think Mrs. Sahani followed this model. Late Professor Sahani's Shanti Swarup Bhatnagar was very helpful to her in generating the funds for government. Recognition of institute's contribution in the field of paleobotany came from solid and monographic work of early researchers. Mostly they were collecting samples and describing them in an evolutionary framework, having little societal impact and relevance to mainstream science, and therefore they were treated as stamp collector by some. The institute was finding difficult in getting funds. Sahani's disciples pushed for complete government support. They in fact succeeded in their efforts, and institute finally got a status of autonomous body under the DST, Government of India. During this period, new discipline of paleopalynology was introduced and nurtured. Scientists were getting trained in the best labs of the world through good offices of Mrs. Sahni and support of UNESCO. Dr. Amin Bose was the first scientist of the country to visit Arctic in 70s and extensively published his research. Institution may be credited with the strengthening of ONGC's Palynology Lab, as those trained in the palynology were recruited by premier oil exploration company of the country. Recognition also came from GSI Coal Wings, which started looking to experts in the institute in correlation of coal seams. During this period, much fanfare was planned for Silver Jubilee celebration of the institute, but it was overshadowed by the hardship of 1971 Indo-Pak War. In the following years, that is 1971 to 1996, BSIP introduced new laboratories, i.e. the carbon dating and archaeobotany, though with some resistance. New instrumentation were added. A need was felt for a new building and more scientific staff. All came through the dedicated efforts of Sahni's students like Professor Surange and Dr. Bose. During these years, a lot of data was generated by researchers. A need was felt to consolidate these results. Sahni Centenary was one such occasion, which saw maximum publications and international collaborations. Pre-cabinet Paleobotany was pursued with vigor. Institute was looked upon as a premier organization in the world of paleobotanical researches. During this period, Institute also celebrated its Golden Jubilee. In the next 25 years of the Institute history, saw several changes in scientific activities. Polar research program was introduced. Quaternary and paleoclimate researches, which were started in 1960s, got new impetus, and geochemistry, Himalayan tectonics, clamp analysis, and palynology and oil exploration were added. In these years, a need was felt that inputs from sophisticated latest instrumentation have considerably increased in paleobotanical researches. A large number of instruments were added. To overcome the space problem, sincere efforts were made over the last 15 years, and at last it has fructified. Soon Institute will have new buildings. Last 75 years have seen the Institute is scaling new heights. The new generation of researchers is there to take the reins, and I am confident that they will take Institute to new heights. 35 years ago, a legendary paleobotanist, Dr. B.S. Venkatachala, spoke on paleobotany in India, Quo Vadis. He traced the development of our science in bygone era and suggested a path for future. There is and there was a lot of concern about the naming of the institute. Even in the early phase, institute name was changed in a quick succession. Within a month of foundation laying ceremony of the Institute of Paleobotany, it was changed to Bilwa Sahni Institute of Paleobotany. Lots of consultation was made and decided to retain the paleobotany in the name. During the last few days after circulation of Platinum Jubilee flyer, I received phone calls from ex-BSIP fraternity regarding the title of my address having the word paleosciences and in the journal. Many of us are taxonomists, and all the taxonomists deliberate a lot on naming a fossil genus and species. They provide etymology for selection of any name, and I am sure consultation must have gone in this process at appropriate levels. Had Mrs. Sahni and Dr. Chala alive, they would have been happier to see growth trajectory of the institute. We reached so far in treating the Sahni's path. Now which direction to follow? Because I have given a title, Quo Vadis. So now which direction to follow? As far as Quo Vadis in the field of research is considered, new potential directions are Ancient DNA Lab, Astrobiology, Paleotropical Botany Center, Cladistic Analysis, and Preparation of Ancient Genome Database are a few disciplines which will be pursued in the institute in the days to come. A new museum of fossil in the country is need of hour to conserve our geoheritage. Institute is the best organization in the country to take up this matter. So I thank you all to have patience to be with me on the 75th year journey of the institute in brief. Thank you.
Thank you so much, sir. That was the journey of Quo Vadis, the present and future that our institute has gone through. And with this, we are coming to the end of the program. And now I request the Push that is there to propose a vote of thanks.
Director BSIP Dr. Vandana Prasad, my colleagues present over here, Professor Chamyal, I have seen you, Professor Subir Sarkar, today's speakers, Professor MP Singh, Professor Kale, all my colleagues of BSIP, and the superannuated staff members of BSIP. A very cherished afternoon to all of you. Today is a very special day for BSIP as we celebrate the 76th Foundation Day of the Institute on this very day. In fact, this year, 10th September is more special because we are celebrating the Platinum Jubilee year. Incidentally, this day became more auspicious because today Ganesh Chaturthi is being celebrated in the country. It is my proud privilege to propose a vote of thanks and acknowledge the contribution of those who worked hard to make this Foundation Day celebration really successful. On behalf of Dr. Vandana Prasad, Director BSIP, and the entire fraternity of the Institute, first of all, my sincere thanks to the Chairman of Governing Body, Professor Nitin Karmalkar, and all the members of Governing Body, Chairman of Research Advisory Council, Professor M.S. Chamial, and the members of RAC for their constant support and patronization. At the outset, I would like to thank Professor Subir Sarkar of Jadavpur University for delivering the Foundation Day lecture on preservational biasness on deposition regimes ranging from Precambrian to recent. Professor Sarkar always remains very busy and he is acquainted with me for a long time. In fact, Professor Sarkar and myself were brought up in the same city and we studied in the same school, though he was senior to me. In spite of his busy schedule, he agreed to deliver today's lecture within a short notice. We all know that he is very prolific and he is one of the finest sedimentologists in India. But at the same time, he is very soft-spoken and down to earth. I hope the early career scientists of the Institute will be highly benefited how we can get the analogy of the modern sedimentary features in the rocks of deep time. He always utters that I do science only for pleasure. You know, Amit, I don't do science for profession. Thanks to my senior colleague, Professor Mukund Sharma, for delivering a valuable talk, Paleosciences Quo Vadis. He very meticulously articulated how the paleoscience is marching ahead. In fact, it reminds me an article written by Dr. B.S. Venkatachala, ex-director of BSIP and mentor of Professor Mukund Sharma. Dr. Venkatachala wrote an article entitled Paleobotany in India Quo Vadis way back in 1986 in the journal Geophytology, Volume 16. Maintaining the legacy of his mentor, Professor Sharma delivered an excellent lecture. I thank from the core of my heart for delivering such an excellent lecture. Actually, some of us, especially our director, Dr. Vandana Prasad, Professor Sharma, Dr. Anjum Farooqui, and myself, witnessed the Diamond Jubilee celebration in 1986, 96, I think. And we have seen the evolution of the Institute in the last 25 years, specifically in terms of scientific excellence. And we also have seen the Institute's transformation from paleobotany to paleosciences. Our director, Dr. Vandana Prasad, is always a constant source of inspiration for all of us, whether it is scientific or any organization activity. Your suggestions and advice enlighten our minds and show up us a new path. On my own behalf and on behalf of all the staff members of BSIP, I extend my sincere gratitude to you, madam. Organization of such event cannot happen overnight. The wheels start moving few days ago. It requires planning and bird's eye view for details. We have been fortunate to be supported by a team of very active and dedicated staff members of our organization who are well versed and dutiful in their job. A special mention to our registrar, Mr. Sandeep Kumar Shivare and his staff, the account section, conveners and members of Publication Committee, Computer Committee, Research Development and Coordination Committee, Staff Welfare Committee and Garden Committee. Apart from that, many of our colleagues work behind the screen. My heartfelt thanks to all of you. Finally, I would like to thank all the viewers who spared their valuable time for witnessing this function in online mode. Thank you very much.
Thank you, sir. Thank you so much for this vote of thanks. With this, I would ask for the program, I announce the closing of this Foundation Day function. With the dedication, determination, team spirit, and sense of temperament, those are the holy pillars of the SIP. And the entire family will, successfully continue the legacy of Professor Sahani and all the directors and all the scientists who have left such a mark and responsibility for us. Once again, congratulations and best wishes for the Platinum Jubilee from the SIP here. Thank you so much for joining us on this virtual platform. Namaskar.